Hello. Let's answer this problem from the 2023 edition of UP Mathematics Club's nationwide search for the Math Wizard. A pair of fair 24-sided dice is rolled numerous times, such that the higher value of the two was taken each time. The probability that the taken values is at most k is 1 over 9. We are asked to find the value of k. Let's visualize the problem by plotting all the possible outcomes for the nodes. We represent each outcome as an ordered pair, illustrated here as the white dots. The horizontal axis represents the result of the first die, and the vertical axis represents the result of the second die. For example, rolling a 6 on the first die and a 5 on the second one gives the point highlighted now. The maximum value between the two is, of course, 6, since 6 is bigger than 5. On the other hand, we get a 4, then a 23. We have the maximum value as 23. What we want is to find or analyze the maximum value of any ordered pair xy. Specifically, we want to check the case when the maximum value is at most k. Since the maximum is k, then both x and y must also be less than or equal to k. So all points whose x and y coordinates are less than or equal to k satisfy the given constraint. So visually, we represent all those points by the golden region shown. Basically, we have a k by k grid of points, which gives a total of k squared points. Now this becomes interesting because we have a finite number of desired outcomes, which is colored gold in this case, and a finite number of total outcomes, which is basically all dots in this grid. We are given that the probability that the maximum value is at most k is 1 over 9. The probability on the left side can be expressed as the ratio of favorable outcomes and the total number of outcomes, as we know from the definition of probability. There are k times k or k squared gold dots and 24 times 24 or 24 squared total dots, and hence the equation becomes k squared over 24 squared equals 1 over 9. So now this is just a simple algebra matter. We multiply both sides by 24 squared. Then we get the square roots of both sides, noting that both 24 squared and 3 squared are perfect squares, and that we only take the positive root for both sides. We get that k is equal to 1/3 times 24, and finally we conclude that k is equal to 8. Therefore, the required value for this problem is k equals 8, and that's our final answer. There are other ways of doing this, but I personally think that visualizing it this way is one of the most efficient way of dealing with this problem. Anyway, that's it for this video. Thank you for watching and see you on the next one. Bye-bye.